Hi again, another question, number 12 from the exam paper. This time we're looking at probabilities with Venn diagrams. We've got a pretty straightforward question here actually. They give you a lot of information. They tell us that this is a number of students at a sporting event. A is a probability that a student is in athletics, T for tennis and C for cricket. P and Q are unknown probabilities. So we've got a lot of information given in the Venn diagram. It also tells us that the probability that a given student is selected at random, if a given student is selected at random, the probability that they take part in athletics and tennis is 0.75. That means athletics or tennis, all of this section is 0.75. So the remainder has to be 0.25. Well, that's great. We've also then got the 0.05 for people that do none of them. So A must be 0.2. P equals 0.2. Let's rewrite that. Going over that reasoning again, the entire area, the entire probability is 1. We need to subtract the 0.75 for the bit that is shaded in pink, where they do either athletics or tennis. And we need to subtract the part where they do neither, and that will give us P. Okay, on to part B. Find the value of P. State given a reason whether or not the events A and T are statistically independent. Okay, first of all, we need to find out what Q is. Well, that's quite straightforward. In this case, we can work out that Q is equal to 0.75, the probability of both bits, minus 0.6, and minus 0.2, the value for P, which gives us 0.15. Therefore, the probability of A, athletics, is equal to Q add P, 0.35. The probability of T, the chance that they do tennis, is 0.6. And that gives us the probability of A times by the probability of T is 0.35 times 0.6, which is 0.21. But the probability of A and T, the intersection, equals 0.2. Then they're not equal, so it's not independent. We need to state that as a conclusion in order to get the marks. So we should state PA times the probability of A times the probability of P does not equal probability of A times the probability of T does not equal the probability of A and T. Therefore not independent. Okay, on to part C. So far, I mean, that's pretty easy so far, I hope. We now need to find the probability that the student selected at random does not take part in athletics or cricket. That would be the probability that we want A or C knotted, and that's 1 minus the probability that they do athletics, 0.35, and take away the probability to do cricket, which is 0.2, which altogether gives us a solution then 0.45. Good.